Welcome dear students. In this video, let us learn about noise trauma, that is noise-induced hearing loss. It is one of the specific forms of hearing loss. Noise trauma. Hearing loss can very well occur because of noise, as noise can damage the outer hair cells, and in high intensities it can also damage the inner hair cells. By and by, noise-induced hearing loss is becoming more important as the awareness of occupational hazards is increasing. So as noise trauma is also considered to be one of the occupational hazard, it's very important that both the employer and the employee are aware of this effect and necessary precautionary measures are taken, especially in some professions such as boiler makers, ironsmiths, coppersmiths, and in some factories which make a lot of noise. This noise trauma is seen. It is an occupational hazard. So hearing loss because of noise can be studied under two headings. One is called as acoustic trauma. Acoustic trauma is permanent damage to hearing by a single brief exposure to a loud noise. One single exposure to a very loud noise and the patient has become deaf forever. Patient is experiencing hearing loss forever, permanent damage. An example of this is, suppose an explosion has occurred, a bomb blast has occurred, or some very high volume crackers, very loud crackers, or a gun firing. Gun firing can also lead to acoustic trauma. These are some examples. But what is to be remembered in acoustic trauma is, it is permanent damage to hearing. Permanent damage to hearing after a single brief exposure. A single brief exposure to a very intense loud sound. A very intense loud sound. Now the terms that are important here are single brief exposure, and that causes permanent damage. A noise that is equal to or more than 140 decibels usually produces acoustic trauma. A gun rifle produces noise somewhere between 140 to 170 decibels. So any noise beyond 140 or equal to 140 decibels range will mechanically damage the organ of Corti. It causes tearing of the organ of Corti. Even the Reisner's membrane can be torn and the tectorial membrane is disrupted. Hair cells are damaged, and this will definitely lead to permanent hearing loss. Apart from that, even the tympanic membrane can be perforated and there could be discontinuity of ossicular chain. This is how acoustic trauma causes hearing loss. The brief mechanisms are tearing of the organ of Corti along with the Reisner's membrane. When Reisner's membrane is torn, there is mixing up of endolymph and perilymph. Endolymph is flowing in the scala media and perilymph is flowing in the scala vestibuli, and the Reisner's membrane is separating both of them. When Reisner's membrane is torn, there is mixing up of perilymph and endolymph. And a severe blast can also damage tympanic membrane and ossicular chain. This will lead to conductive type of hearing loss also. And this exposure could be for a very brief amount of time, as brief as 0.2 milliseconds is enough to cause acoustic trauma. So no impulse more than 140 decibels is allowed. 140 decibels is the maximum limit. More than 140 decibels, it is not permitted. This is about acoustic trauma. And the second type that we have is noise-induced hearing loss. Noise-induced hearing loss. In short, NIHL. In this case, in noise-induced hearing loss, it is not a single exposure, it is a chronic exposure to less intense sounds, not as high as 140 decibels. But these can also, over a period of time, can cause hearing loss. So, NIHL is chronic exposure to less intense noises. If it is more than 140, it will directly cause acoustic trauma. Less intense noises over a period of time will cause noise-induced hearing loss. And here, first thing that happens is a temporary threshold shift. What is a temporary threshold shift? Initially, after exposure to noise, hearing is impaired immediately, but the patient again recovers, and that recovery time could be a few minutes, hours, or it might even take days. That depends on the amount of noise he has been exposed to, its frequency, and for how long he has been exposed to. So that is temporary threshold shift. Hearing is impaired immediately, but later recovers. The patient recovers after a certain interval of time. That is temporary threshold shift. Hearing is impaired immediately on exposure, but recovers after a time interval, and that time interval could be anything between a few minutes to days. It depends upon the noise. Second is permanent threshold shift. What is permanent threshold shift? Here the hearing impairment is permanent and the patient does not recover at all. Hearing impairment is permanent. No recovery. Now this permanent threshold shift is different from acoustic trauma. Permanent threshold shift also occurs after chronic exposure and it is preceded by temporary threshold shift. So a patient has been exposed to some noise and then he undergoes hearing impairment, and after a period of time slowly he recovers. And then repeated episodes of such exposure will finally lead to a permanent threshold shift. In acoustic trauma, there is no preceding event like that. There is a single episode. There is no temporary threshold shift in acoustic trauma, whereas a permanent threshold shift is always preceded by a temporary threshold shift. Now, noise-induced hearing loss depends upon certain factors of noise. NIHL depends on some features of noise such as, first one is the noise frequency. A noise in the frequency range of 2000 to 3000 Hz causes maximum damage than the ones below and above 2000 and 3000. 2000 to 3000 frequency Hertz range will cause maximum damage. Second is the intensity and duration of noise is another important factor. Intensity and duration. If you increase the intensity, duration of noise has to be reduced. The exposure period has to be reduced. We have some guidelines defining it, which I will discuss later. Next, there is something called as continuous noise versus interrupted noise. Continuous noise is a person is working in a factory where there is continuous machinery murmur, machinery noise. That is more dangerous than somebody working at interrupted noises. In between, once in a while noise is coming and going. Continuous noise is more dangerous than interrupted noise. Continuous noise causes more harm than interrupted noise. Then, there is susceptibility of the individual. Individual variations are present. If two people are exposed to the same noise for the same amount of time, they both still respond differently. That is their individual susceptibility. Even the recovery time in temporary threshold shift. I repeat, even the recovery time in temporary threshold shift differs among different individuals because of their individual susceptibility. And last is pre-existing ear diseases. In a patient with pre-existing ear diseases, the effect of noise is even higher. These are some of the factors affecting noise-induced hearing loss. Now let us look into the guidelines given by recommended by the Ministry of Labour, Government of India. What are the guidelines? A noise of 90 decibels for 8 hours a day, like that for 5 days per week, is allowed. A noise of 90 decibels 8 hours a day for 5 days in a week is the maximum safety limit. Up to this, it is allowed. Beyond this, it is not allowed. But we have another rule called as the rule of 5 decibels. If we increase the sound by 5 decibels, the duration of exposure is halved. For example, from 90, if I make it 95 decibels, then the person can be exposed to the sound for 4 hours per day. If I increase to 100 decibels plus 5 decibels, then he is allowed to be exposed to it for 2 hours per day maximum. This is the rule of 5 decibels versus time. As we increase the sound by 5 decibels, the duration of exposure is halved. This is the 5 decibel time intensity rule. Then, the Noise Pollution Rules Board by the Ministry of Environment and Forest, Government of India, has given permissible limits of noise for various zones around hospitals, educational institutions, courts. A 100-meter silence zone must be present. 100 meters radius around these areas, silence should be observed in the premises of hospitals, educational institutions and courts. And also, there is a limitation for the manufacturing of crackers. More than 125 decibel sound crackers should not be manufactured. So these are the two rules. One is the sound intensity versus time. 90 decibels, 8 hours per day for 5 days a week is the standard maximum limit that is allowed. If we increase 5 decibels, the time has to be reduced by half the amount. 95 decibels, 4 hours. 100 decibels, 2 hours. Like that, maximum we can go up to 115 decibels. This is maximum. Beyond 115 decibels is just not allowed. These are the two guidelines given by the Government of India. Next, if we observe the clinical features, next, if we look at the audiogram, if we perform pure tone audiometry on a case of noise-induced hearing loss, the most important and classical feature is a dip is seen at 4000 Hz frequency. A dip at 4000 Hz frequency. The moment I say noise-induced hearing loss, a dip at 4000 Hz frequency seen in audiogram should come into your mind. This is the most classical characteristic feature of noise-induced hearing loss. And when we are plotting the audiogram, two stages are seen. First is the early stage. In early stage, the patient complains of difficulty in hearing in noisy surroundings, but in day-to-day hearing he is okay. And also there is high-pitched tinnitus. In early stage, the features that we observe are high-pitched tinnitus, and difficulty in hearing in noisy surroundings only. In normal day-to-day life, he is okay, he is able to hear. Only in noisy surroundings, hearing is affected. This is the first stage. And also, we see a dip at 4000 Hz. At this stage, there is noise-induced hearing loss in both the ears. It is bilateral and the graph is symmetrical. Now, noise-induced hearing loss affects the outer hair cells more than the inner hair cells, and initially the basal turns of cochlea are affected, and later on even the apical coil is affected. So, it widens to involve. Initially it is at 4000 Hz, it widens to involve the lower and higher frequencies also. So in the late stage, here the 4000 Hz notch widens and deepens. The notch widens and deepens, involving frequencies such as 500, 1000 and 2000 Hz also. At this stage, it becomes clinically apparent to the patient. The patient realizes that he is suffering from hearing loss, and also there is hearing loss in normal day-to-day environment, not only in the noisy environment, even in the normal environment his hearing is affected. Clinically apparent hearing loss. This is about the audiogram and the stages of noise-induced hearing loss. Now, most important fact about noise-induced hearing loss is that it is preventable. It is a preventable cause of hearing loss. So, how do we prevent prophylaxis of noise-induced hearing loss is done by three simple ways. One is pre-placement, pre-employment, and annual audiograms. Annual audiometry should be performed on every single employee working in the noisy surroundings before taking him into the job, and also every year thereafter an annual checkup, pre-employment and annual audiometry has to be done. This facilitates early diagnosis so that we can identify changes of noise-induced hearing loss in the patient. And second most important is ear protectors have to be used. As simple as cotton wool can be placed in the ear. We can use ear plugs or ear muffs can be used, and these provide a protection of up to 35 decibels. They offer a protection up to 35 decibels. So if the patient is exposed to let us say 90 decibels, he will be exposed only to 55 decibels by using ear protection equipment. So they are that useful, and it should be made mandatory in all the employees. And third is rehabilitation of those employees in whom noise-induced hearing loss has already occurred, or in the early stages itself when we identify, we have to rehabilitate them. This is the prophylaxis. So about noise trauma, we have learnt first is acoustic trauma, second is noise-induced hearing loss, and there is a third component to this. That is, the third component is non-auditory effects of noise. Non-auditory effects of noise. Apart from hearing loss, noise can affect other systems of the body also. Noise exposure causes chronic fatigue and stress. It can affect the rest and sleep cycle of the body. This is very important. It can cause chronic fatigue in the person and even stress. Now the best example for this is, if you talk to traffic policemen, they will tell you how fatigued they feel because of all the vehicular noise pollution that they are exposed to. And second, it can affect the autonomic nervous system and it can lead to irritability and annoyance. The person is always irritated. Irritability and annoyance. Exposure to noise can cause this. Even hypertension and peptic ulcer have been noted in people who are constantly exposed to noises. Also, being in a noisy environment affects the performance of the individual where communication through speech is required. Best example for this is school teachers in a classroom. In a noisy classroom, not just school teachers, any teacher for that matter, when they are teaching in a noisy environment versus teaching in a silent class, the efficiency is definitely better while teaching in a silent environment. Or any speech that is being given anywhere, where instructions have to be followed, the efficiency is definitely better in a silent environment than in a noisy environment. Effects. Performance. Next, in people who are working in a noisy environment, to be able to heard, they're putting excess strain on their vocal cords, so laryngeal problems have been observed. Laryngeal problems such as vocal nodules or vocal polyps have been observed in people who are working in noisy environments and who are trying to speak loud all the time to be able to be heard. So these are the non-auditory effects of noise. With this, I complete noise-induced hearing loss. Let us briefly recap everything. Noise trauma causes acoustic trauma, that is permanent damage to hearing after a single brief exposure. The exposure could be as low as 0.2 milliseconds and the sound is somewhere around 140 decibels. Anything 140 or more than that will cause acoustic trauma. There is no preceding temporary threshold shift in acoustic trauma. What happens exactly is there is tearing of the organ of Corti and Reisner's membrane. The entire auditory apparatus is damaged and destroyed. The hair cells are damaged and destroyed. There is mixing up of perilymph and endolymph because of Reisner's membrane damage. Next is noise-induced hearing loss. This is chronic exposure to noise but to a less intense noise, not as much as that seen in acoustic trauma. Here two things occur. There are two stages. First is temporary threshold shift. Initially the patient experiences hearing loss but recovers after a time interval. That could be anything between a few minutes to a few days. It depends upon the intensity of noise, frequency of noise and the duration to which he has been exposed and also the individual susceptibility of the person. Then in the next stage there is permanent threshold shift where the hearing impairment is permanent and there is no recovery. And noise-induced hearing loss depends upon factors such as noise frequency, the intensity and time duration to which the person has been exposed, whether it is continuous or interrupted noise, continuous being more harmful, and also individual susceptibility. This is important, plus pre-existing ear diseases. These are the 5 factors. Noise frequency range of 2000 to 3000 Hz. Then some guidelines are given by the Government of India and they are: a person should be maximum exposed to 90 decibels for 8 hours per day for 5 days a week. This is the maximum safety limit. According to the 5 decibel time intensity rule, if we increase the sound by 5 decibels, the duration of exposure should be halved. 95, 4 hours. 100, only 2 hours. With this rule also, the maximum sound that is permitted is 115 decibels. Beyond that is not allowed. And also, around hospitals, educational institutions and courts, a silence zone of 100 meters should be followed. If we take an audiogram, perform audiometry on a person with noise-induced hearing loss, the most important feature that we see is a dip at 4000 Hz frequency. Just by looking at an audiogram and a dip at 4000 Hz frequency, you can diagnose that it is a case of noise-induced hearing loss. And it is bilateral and the graphs are symmetrical on both the sides. So in the early stage, the patient experiences a high-pitched tinnitus and difficulty in hearing only in noisy surroundings. Normal day-to-day conversations and hearing in normal environment is good. And there is a dip at 4000 Hz. In the late stage, this notch widens and deepens. The hearing loss is much more and it covers more frequencies on either side of 4000 Hz, and clinically apparent hearing loss occurs. Not just in noisy surroundings, even normal day-to-day activities of the patient are affected. And prophylaxis of noise-induced hearing loss can be done by putting ear protectors, and annual pre-placement and annual audiometric evaluation of the person should be done. And finally, rehabilitation of the patient. Non-auditory effects of noise are chronic fatigue and stress, irritability, annoyance, even hypertension can occur. Plus, performance of the person is affected in noisy environment where speech has to be used. Plus, constantly speaking in noisy environment, more or less shouting in noisy environment to be able to be heard gives rise to laryngeal problems in the speaker. Thank you very much.